Good morning. The next set of instructions is called properties of exponents. So the first one is the product of powers property. So this is called the base. Your a is the base and your m is the exponent. So here's a simple rule, and I'll walk you through it so you'll think it's simple too. So I'm taking my base of a and my exponent of m, and I'm timesing it by a to the n. All that it does is you keep your base the same and you add the exponents, so m and n in this scenario. So this is a refresher of what an exponent is. So 3 to the second is just 3 times 3, which is 9. So when you're given a problem like this, 3 to the second times 3 to the second, you just expand it. 3 to the second is here, then 3 to the second is here, and that really is 3 4 times. So if I'm given one like this, 3 to the fifth times 3 to the first, if I wanted to expand it, I have my 5 threes and my 1, and I could multiply it out. But if it's an exponent form, they want you to keep it. So in this scenario, it would be 3 to the sixth. You're just adding those exponents. So now, I'll give you a couple examples. If I had 4 to the second times 3 to the second, that written out is 4 times 4 times 3 times 2 times 2. You cannot combine it to be 8 to the fourth. You can't multiply the 4 and the 2's and then just add the exponents. The bases are not the same. So you really have to expand that one out and actually find the number there. So here's another example of how I have 4 with no exponent. It's really an invisible 1 up there. A to the second times 3a to the fifth. I take my whole numbers because they don't have the other exponents like up top. So this is really 4 to the first and 3 to the first, right? So 4 times 3 is my 12. Now I have my base here of a and a base here of a. So I keep that a because they have the same base, and I just add those exponents. So 5 and then 2 is the 7. So I have the 12a to the 7th. This one has a lot more going on. 2 and the 3 are not the same base, but it's just regular multiplication in this scenario. So I have the 2 times the 3, so I got my 6. And now I go back to my base of an a and my base of an a here. Now the rule that we just talked about is taking our bases. If they're the same, I add the exponent. There's an invisible 1 right there. Not a 0. That's very important to understand. So I have a to the first and a to the third. I just add those, and it becomes a to the fourth. The next step, this one doesn't have a c. This one does. So there's nothing to add on. It just gets tagged on to the end. Okay. I'll show you another example. If I have a whole number out front, it does not matter if they don't match, as long as you can still multiply them. I have 4abc to the fourth and 2a to the fourth, c to the first. So I take my whole numbers. If it were an exponent like this, I would have to multiply that first. So I would have to do 4 times 4 and change this to a 16 first. Let me erase that just for simplicity for this one. Take my whole numbers. 4 times 2 is my 8. Now my a here, that 4 does not go with this a. There's an imaginary 1 right there, just like there's an imaginary 1 right there or right here. So my a and my a, I keep my base of an a, I add my exponents, which becomes my 5. Now I take my b, and this one doesn't have a b, so I keep the b with that single exponent there. I can write that one, I don't have to. And then my c's, c to the fourth and c to the first becomes c to the fifth.